So welcome to my channel. So in this video, I will show you how to work with MODIS dataset uh, and how to work with net primary productivity, how to show on the chart the annual mean net primary productivity, which was computed by MODIS in Google Earth Engine. We will work with this image collection in Google Earth Engine mod 17A3HGF.061, which has information about the Terra net primary productivity. So Terra means land, Earth surface net primary productivity, gap filled yearly globally. So the pixel resolution is 500 meters. So we can see, so this is the name of the image collection in Google Earth Engine. You can read the information here, but I want to focus on this attributes of the image collection. So it has gross primary productivity, net primary productivity, and net primary productivity quality control. So we will need net primary productivity. It's in yeah, I fixed English. It's in kilograms of carbon per square meter. So in this case, for instance, let's take one pixel, 500 meters to 500 meters. It will be 25,000 square meters. No, it's not 25,000. It's actually 250,000. So 250,000, it will be 25 hectares of the area of one pixel. In this case, it will show what is the average annual net primary productivity of carbon in kilograms for this pixel on per square meter. For instance, let's take one pixel. It's, as I mentioned, 500 square meters, so it's one pixel. So it has this 250,000 square meters of land. So let's say that so this minimum value is minus 30,000, maximum is 32,700, but this is the pixel value. We need to scale it to 0.0001. So we have to divide it, for instance, to 10,000. So in this case, it will be 3.2 kilograms. 3.2 kilograms of carbon per square meter is the maximum net primary productivity for the globe. I think it's close to this Amazon rainforest. So let's example that 3 kilograms per square meter of carbon multiplied to 2,500,000. So it will be 800,000 kilograms of carbon. We can divide it into 1,000. It will be 1 ton. So 800 tons of carbon for the whole pixel area for the year. This is a maximum level. Of course, it's in general it's much lower. It's for Amazon rainforest. We will have to scale it in our Google Earth engine. So let's go back to the Google Earth. First, I will upload my FAO image feature collection level 2, because I will work with a certain area called the Shahrisabz district in Uzbekistan. So and then I will create this variable area and filter from this FAO my study area, the Shahrisabz district. It's in containing the attribute named ADM2 name, and I can run. So this is my FAO image collection. I don't need it, and this is my study area filtered from FAO image feature collection. And let's move forward. So now I will upload this image collection, MODIS, this image collection. You can copy as well from here. Image collection MODIS, which contains information about the net primary productivity, and this is the range from 2001 to 2024, but I think it's later on as well, but let's rely on this information given in Google Earth developers. So 2024, so from the beginning till the end, it's 24 years, and I have to select the band net primary productivity. So it has several bands, gross primary productivity, net primary productivity, and this one. So I need net primary productivity. You can also compute gross primary productivity as well. And I select, and I have to scale it, right? So don't forget it to scale, because otherwise it will give you just pixel values. So I create map. I map through the image dataset image collection. This function image, which will return the clipped area. I have to clip it for my study area. This is my variable Shahrisab's name, and I have to multiply it to 0.000. This is a scaling factor which will convert the pixel values into this kilograms of carbon per square meter. And I will copy properties of the date, system time start. So this dataset will contain the information of net primary productivity for my study area, average annual net primary productivity for my study area, which is scaled. The next thing, as far as I have to show in the chart, the average net primary productivity for my study area and study period ranging from 2001 to 2004. At 24, I have to create a mean value. This one as well, using reducer function. So I will create mean net primary productivity variable, and I will map this data set using the function. So mean image reduced region, I will use the reducer, so it will take all the pixels and reduce it to the mean. So it will take all the pixel values and sum them and divide into pixel quantity, which will show the mean NPP annual for the whole study region. So that's why this is my area. Scale is to 500 and maximum pixel value is this. And eventually so this is a future collection, and because it will return future, if future null, I don't need geometry, only need the year and mean NPP. So year, it will have the two attributes: year, date, image, system type, stamp, get year, and it will have the mean net primary productivity, get NPP. And now the next step is to use chart function, because this is information. So this is not feature collection, sorry, this is just we can actually print them, print this is information of data. So we can see that it's mean NPP. I will create mean first, mean NPP. So I can so far close this, and let's see what we have so far. So it's just it's a feature collection, but it doesn't contain features or geometries. It contains just information. So see that this is a date. It will assign the January 1st date because it's for 2001, and it has the year information and mean net primary productivity information for the whole study area for this year. See, and I need to just show this in the chart, because just so far it's just information, numbers. So I will create well, we can close this chart, NPP chart, using UI chart future by future. So there are many ways to show the chart. In this case, as far as I'm using as this future collection, I will use future by future chart. So mean NPP, year, mean NPP. So you can read about this chart type in Google Earth Developers. So set chart type, it will be line chart, and options. Well, I will name it mean annual, and as a title, NPP in Shahrisabz district from 2001 to 2024. X-axis here, y-axis it's NPP in kilograms per of carbon per square meter per year, and line. So you can choose your attributes and characteristics for chart. Let's test it. So it has so it will take this feature collection and map it so we can see here and it will show it as a chart. So we see that it fluctuates mean annual net primary productivity for the study area. So it ranges from, it's for whole pixels in general, average for the whole area. So from in 2001 from 0.22 it means kilograms. Yes, it's for for per square meter. It's not for 1 pixel, it's per square meter. You can take the whole study area territory and multiply it, and you will see that volume of the NPP total. For instance, let's say 0.21, it's in kilograms per square meter. So let's say that our study area is 1 million 1 million square meters. In this case, it will be for the whole study area, mean annual NPP will be this 2,200,010 kilograms per year. We can divide it into 1,000. It will be 210 tons of net primary productivity for the whole study area. And as we see that it fluctuates, sometimes it reaches this value 0.28. So this is 1 year 2018, this is another year 2020. So net primary productivity fluctuates. It depends on many factors: agricultural productivity, for instance, good precipitation, whether it's overgrazing or not overgrazing, urban expansion or not urban expansion, land rehabilitation or not, etc. Many factors. So let's also see how it looks on the map. Mean NPP per pixel. So I will just now show the average NPP for the whole study period from 2001 to 2024. If it shows, the chart shows the average annual NPP for the whole study area, I will show you the spatial variation of the pixels, for the whole study period. Yeah, I forgot to visualize. So NPP, it can be different, it depends on study area. In my case, from 0 to 0.7 per square meter. NPP from 2002 in kilograms. Yeah, it doesn't matter. So let's run. Yes, this is my study area, and this shows this NPP range. So the green areas have high NPP, and this brown areas have low NPP. These are mountain areas. We can inspect, for instance. Yeah, by the way, we can see what is the maximum and minimum value. Let's stretch it. So see that pixel value differs from the total mean annual value. It ranged from 0.04 to 0.5 54. So yeah, it's spatial variation for the whole study period differs. So this is the green areas. This is well, it's more close to agriculture, but this is for the whole study period for 24 years from 2001 to 2024. But the annual variation also varies. So these areas are the green ones, high net prime productivity, low, and something bit in the middle. So let's save it. You can also export this one. You can also export this in CSV format or in SVG or in PNG formats, and you can analyze it in Excel.